This concerns the first question on the in-class quiz, the ungraded quiz. That concerned Mrs. Smith has 3 kids, 1 boy. How do you solve this? It's tricky. On the one hand, question mark, you might say, well, if there's no order specified, are we just thinking about the possible arrangements of kids? You could have 3 boys, you could have 3 girls, you could have a couple boys and a girl, you could have a couple girls and a boy. And that would be all the possibilities. And then the probability that she has just 1 daughter would be 1/4, right? 1 out of 4. Actually, it wouldn't be that, because you know actually that she doesn't have any girls. So then it would be 1/3. 1 possibility out of 3. So it'd be a 1/3 chance. Now, what's wrong with this approach? Well, there are a couple of things. Suppose that 2 individuals have a child. So time goes on, they have a child, and what are the odds of that child being a boy or a girl? Well, in the one case where you have, say, a boy, there's a 1/2 probability that you'll get a boy, and then there's a 1/2 probability that you'll get a girl. Now, time wears on and the family decides to expand. What are the odds that they have another boy? So there's 1 boy and here's another one. So boy, boy, versus their second child being a girl. So here's the older brother and here's the younger sister, G. Well, this is also 50%. They are, to a large degree, independent events. Let me tilt this slightly. Same thing goes down here. In the case where the first child was a girl, there are 2 possibilities. The family might have a second child that is a girl, another girl. So you have a pair of sisters, girl, girl. I have a pair of girls myself. Or you might have a case where your first child was a girl and your second child is a boy. What are the odds of that? Those are still 50%. Now, for a family of 3 children, this repeats one more time, and I won't bother you with drawing those. So what are the outcomes? Well, you could have boy, boy, boy. You could have boy, boy, and a girl. Finally, you could have boy, 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 girl, boy, boy, girl, girl. We're down here where girls were the firstborn. You could have 2 girls and then a 3rd girl, 2 girls and then a boy. Or you could have a girl, a boy, and then another boy, or a girl, a boy, and another girl. So these outcomes are all equally likely. Now, what's the difference? Does it make any difference? Well, it does. Notice that the odds of having 3 boys are 1 in 8 in this scenario. While up here, if we don't care about the order, it's 1 in 4, ignoring the original question. That's twice as likely. Well, it can't be both. Either you can have 3 boys 1/4 of the time or 1/8 of the time. So which one is it? Let's think about that. Likewise, what about the odds of having at least 1 boy? Well, there's lots of situations that involve at least 1 boy. That's 7/8 of the time versus 3/4 of the time. Those are different numbers. So this is a little like the dice problem in the sense that when you roll a pair of dice, I have some handy here, you can't tell which one is which. So if I roll a pair of dice, That's a 1 and a 5. Suppose I roll these again, and I get a 5 and a 1. Now, I did that in a way that you can tell that this was the 1 before, and this was the 5. So this is the other arrangement. But in general, you can't tell which one has happened. But the odds of having a 6 do depend on there being 36 different outcomes. If we count a 5 and a 1 the same as a 1 and a 5, we would predict getting a 6 less often than by counting both cases. So even though it doesn't seem like order is implied here, order does matter. And it might help to think of it as a family actually going through the process of having children along the way. There are 8 outcomes for a couple trying to have 3 children. And those 8 outcomes are largely equally likely. And then the odds should be based upon these possibilities, not on these possibilities. This would be a bit more like the case, well, I don't know, yeah, I'm not going to comment. So how do you solve the problem I asked you? Well, so there are 8 possible outcomes. Girl, 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 boy, girl, boy, boy, girl, boy, girl. And then sort of the opposite. I've ordered Thai food, and I wonder if they're going to knock here at any minute when I finish this up. Now, this question is a conditional question. You're told she has 1 boy. You can eliminate this. This is not an option. So out of the remaining options, what are the odds that she has exactly 1 girl? Well, that would be either that one, or that one, or that one. There are 3 options remaining out of 7 possible options. So 3/7 is the probability that she has exactly 1 boy if she has 3 kids. I'm sorry. 3/7 is the probability that she has exactly 1 daughter, given that she has 1 boy out of the 3 kids.